Your LLM agent finished running. It configured 12 tools, called 5 APIs, set a dozen parameters, and you have no idea if any of it is correct. That's not a hypothetical. That's what happens every single time you run an agentic workflow without a way to inspect what the agent actually decided. ATO Agentic Tool Optimization is a GUI that shows you exactly what your agent configured, parameter by parameter, and lets you fix it before something breaks. Here's what's actually happening under the hood when you deploy an LLM agent. The agent doesn't just run your code. It makes decisions. It picks tool configurations, sets values, chooses paths. And most of the time, those decisions are invisible. They happen inside the model's reasoning loop, they get applied silently, and you only find out something went wrong when your pipeline fails, or worse, when it produces bad output that looks fine on the surface. ATO intercepts that process. When your agent configures a tool, ATO logs every decision into a visual interface. You see the tool name, the parameter, the value the agent chose, and why pulled from the agent's own reasoning trace. It's structured, it's readable, and it's all in one place. You're not digging through JSON logs or grep.ing through output files. You open the GUI, and the entire configuration state is right there. The fix workflow is the part that surprised me. You don't just read what the agent did, you can edit it. Click on a misconfigured value, type the correct one, and ATO pushes that correction back into the agent's configuration state. That means you can catch a wrong API endpoint, a bad timeout value, a miscategorized tool parameter, and correct it before the agent runs the next step. That's the difference between debugging after the fact and actually being in control. Now let's be honest about what ATO does not do. It is not an autonomous fixer. It does not detect misconfiguration on its own. It has no built-in validation rules that say this value is wrong. You have to know what a correct configuration looks like to use this effectively. If you're a beginner running your first agent, this tool won't tell you what's broken, it'll just show you everything the agent decided, and it's on you to recognize the problem. It also doesn't integrate with every agent framework out of the box. Right now, the setup requires some manual wiring to connect your agent's tool configuration output to the ATO interface. There's no one-click plugin for LangChain, AutoGen, or Crew AI yet. That's not a deal breaker for an experienced developer, but it does add friction for anyone who was hoping to just install and go. And it's a GUI tool, which means it lives in your local development environment. It's not a cloud dashboard. If you're running agents in production at scale, on a hosted server, you'd need to figure out how to expose or export that configuration data to where ATO can read it. That's a solvable problem, but it's not solved yet out of the box. If you're already deploying agents on a cloud provider like DigitalOcean, getting that data piped into a local dev tool adds a step. But here's the thing, the future potential here is significant. Right now ATO is a viewer and editor. But the data it's already collecting is exactly what you'd need to build automated validation. Imagine defining a schema for what a correct tool configuration looks like, allowed value ranges, required parameters, forbidden combinations, and having ATO flag violations automatically before the agent moves on. That's one contributor away from being a reality. There's also a pattern matching angle. If you run the same agent workflow 50 times, ATO is accumulating 50 snapshots of agent decisions. That's a dataset. You could start identifying which configurations the agent gets wrong repeatedly, build correction rules from that, and eventually fine-tune the agent itself to stop making those mistakes. The GUI is the starting point. The audit trail it creates is the real asset. Multi-agent systems are the other obvious evolution. When you have 5 agents passing tool configurations to each other, tracing which agent set which parameter and when becomes genuinely hard. ATO's per-decision logging is exactly the kind of structure you'd need to build a proper audit trail across a multi-agent pipeline. So why does this exist? Because the core assumption most developers work with, that if the agent ran without errors, it ran correctly, is wrong. LLMs make plausible-sounding decisions that are subtly off. They'll set a timeout to 30 seconds when your API needs 90. They'll pick the wrong tool variant because 2 options had similar names. They'll configure a parameter they weren't supposed to touch at all. None of that throws an exception. all of it causes problems downstream. The developer who built ATO hit this exact wall. Running agentic workflows, watching them complete successfully, and then spending hours figuring out why the output was wrong only to find that the agent had misconfigured a single parameter deep in the tool setup. There was no way to see it without building something. So they built it. If you're building with agents seriously, not toy demos, actual pipelines that do real things, ATO is worth looking at. It won't make your agents smarter, but it'll make you a smarter operator of those agents. And right now, that gap between what agents decide and what humans can see is one of the biggest invisible risks in production AI systems. Next episode, we're looking at a tool that takes the opposite approach. Instead of letting you fix agent decisions after the fact, it constrains what the agent can decide in the first place. Same problem, completely different philosophy. Subscribe so you don't miss that one.